This is the final tutorial video for the optional bonus project with the food drive. This is answering the question, if you ate one serving size of the food, how many grams of fat, which is C57H1O4O6, could be metabolized through combustion using the heat evolved? And they give us a delta H value. So first, they tell us that it's a combustion reaction. So what that means is we have this hydrocarbon, we have fat. Combustion means we're adding oxygen, and we are producing CO2 plus H2O. So we have an equation for the combustion reaction, and the first thing that needs to be done is this needs to be balanced. We need to balance the C's, then the H's, then the O's. So what you need to do is you need to go through and balance the C's, then H's, then O's. Don't forget that you have 6 oxygens here and you have the O2 here. So you need to balance this combustion reaction. After you have your combustion reaction balanced, the problem says that you are eating one serving size of the food. So you can see up here, I'm using the Easy Mac. And what I did in the very first part of the bonus project is that I found that Easy Mac has 962,320 joules of energy in one serving size. So what this becomes is a thermochemical equation, because they gave us the delta H value in the problem. It says the delta H is negative 3.022 times 10 to the 4th kilojoules per mole. So that means that 3.022 times 10 to the 4th kilojoules of heat is released, because it's negative, per 1 mole of reaction, which means that that matches up with every coefficient in the balanced equation. So this delta H is how I go between heat and moles. So what I need to do, if I know I need to do kilojoules, is I'm going to start by converting my joules to kilojoules. Then I'm going to use my delta H value. So I am going to use 3.022 times 10 to the 4th kilojoules. And then the problem is asking me to go to grams of fat. So I need to go to moles of C57H1O4O6. So whatever my coefficient is for fat, that's what is going to go here in my dimensional analysis problem. And then the last thing is to go from moles to grams. So this moles to grams, this is going to be the molar mass of fat, C57H1O4O6. So you need to add up all of these atoms, all these elements, to get the molar mass. So then what you have is now you have just a stoichiometry problem. We're just stoiching with thermochemical equations. So whatever your coefficient for fat is, that's what goes here. And then you can calculate the molar mass of C57H1O4O6. That goes into here. And then we just solve. We multiply across the top. We divide by what's on the bottom. Now, if you're asking where the negative went, well, technically if we're eating a serving size of food, we would be using that energy, so both of the negatives would end up canceling. Also keep in mind that grams have to be positive. So we need a positive number for mass, which is why I just dropped the negative.